Our planet holds a remarkable secret. It is a story hidden deep within its rocks and oceans. For billions of years, Earth has been quietly rearranging its face. This is not a gentle process. It is a dramatic saga of colossal landmasses rising and falling. These immense continents, known as supercontinents, completely reshaped our world time and time again. They are more than just ancient maps of a forgotten past. These giants of stone dictated the planet's climate for hundreds of millions of years. They were the architects of evolution, forcing life to adapt or perish. And they literally moved mountains, creating the very landscapes we see today. Imagine our planet not as a static blue marble, but as a living, breathing entity. Its skin is not fixed. It is a mosaic of gigantic plates that are constantly in motion. These plates carry the continents we know today, drifting across a sea of molten rock deep within the Earth. Over immense spans of time, these wandering continents collide. They merge together to form one single vast landmass. This is a supercontinent, but like all giants, they are destined to fall. Forces from within our planet inevitably tear them apart, scattering the pieces once more across the globe in an endless, slow-motion dance. This grand cycle has been repeating for almost the entirety of Earth's history. It is a rhythm that beats on a timescale almost too vast for us to comprehend. The evidence for this epic story is all around us, if we know where to look. It is written in the magnetic signature of ancient lava flows. It is preserved in the fossilized remains of creatures that lived on opposite sides of today's oceans. The clues are even etched into the great mountain ranges that stretch across different continents, like matching scars from a long-forgotten battle. Join us as we piece together the clues and reveal the epic saga of our planet's shifting face. These are the A-listers of ancient Earth, the supercontinents whose names echo through geological time. The most well-known of these is, of course, Pangea. This was the world of the early dinosaurs, a single, immense landmass that existed roughly 335 to 175 million years ago. It stretched from pole to pole, surrounded by a single global ocean, Panthalassa. Before Pangea, there was Gondwana. This was a southern supercontinent that included South America, Africa, Antarctica, Australia, India, Arabian Peninsula, a separate world that would eventually collide with another great landmass to the north, Laurasia, to form the even larger Pangea. Going back even further into the mists of deep time, we encounter Rodinia. Its assembly and breakup reshaped the planet, possibly triggering snowball Earth, where ice may have reached the equator. The most classic clue is the remarkable fit of the continents. Look at the coast of West Africa, the east coast of South America. They match up like two pieces of a jigsaw puzzle, a hint of their shared past. Imagine you are walking along a mountain range in the eastern United States, the Appalachians. Now travel across the Atlantic Ocean to Scotland, Scandinavia. You find the same rock types, the same age, the same structure. It is as if a single gigantic mountain chain was torn in two. This is precisely what happened when Pangea broke apart. For example, the fossil of a small Triassic reptile called Lystrosaurus has been found in South Africa, India, and Antarctica. This creature was not a swimmer. It could not have crossed the vast oceans that separate these lands today. The only logical explanation is that during its lifetime these continents were joined together. Glossopteris, the tongue-leaf seed fern. Glossopteris fossils appear across Australia, South America, Africa, India, Antarctica. When molten rock cools and solidifies, tiny magnetic minerals act like microscopic compass needles. They align with Earth's magnetic field at that moment and are locked in place. This field is called paleomagnetism. When polar wander paths for two continents, North America and Europe, match, then diverge, it's powerful evidence they were once joined and then split. New ocean floor at mid-ocean ridges records these reversals as it cools, creating magnetic stripes on either side. The pattern is perfectly symmetrical, a barcode-like record of seafloor spreading. Together, these clues, the puzzle piece fit, the matching mountain ranges, the identical fossils, the ancient climate evidence, the magnetic records locked in stone, create an overwhelming case. The movement of these plates is driven by a powerful engine deep within our world, its molten heart. This continuous circular flow of rising and sinking rock is a process called mantle convection. These colossal convection currents are the heartbeat of our planet. They exert a powerful drag on the bottom of the tectonic plates floating above them, pulling and pushing them across the globe. The movement is incredibly slow, typically only a few centimeters per year, about the same speed that your fingernails grow. Here, two plates are being pulled apart by the underlying mantle currents. As they separate, molten rock, or magma, from the mantle rises up to fill the gap. This destruction happens at subduction zones. These are places where two plates collide and one is forced to dive beneath the other, plunging back down into the mantle. Oceans are born at spreading centers, and they grow as seafloor spreading continues over millions of years. This subduction starts to close the ocean basin, pulling the continents on either side closer together. When two continents collide, neither one can be subducted. Instead, they crumple. The immense pressure buckles and folds the rock, thrusting up gigantic mountain ranges. Using sophisticated computer models, geologists can project the current movements of the continents forward. In time, one prominent theory predicts the formation of a supercontinent called Pangea Ultima. Eventually, in about 250 million years, the Americas will slam back into the merged Afro-Eurasian landmass. Another compelling model leads to a different outcome, a supercontinent known as Amasia. The result would be a supercontinent clustered around the North Pole. But what is certain is that our current world map is just a temporary snapshot in Earth's long and dynamic history. The continents are on an unstoppable journey. The formation of a supercontinent does more than just redraw the world map. It fundamentally changes the planet's climate system. Ocean currents, the planet's great circulatory system, are blocked and rerouted. Moisture-laden winds from the surrounding ocean cannot penetrate deep into the continent's heart. Any rain they carry falls near the coast, leaving the interior incredibly arid. If a large portion sat over a pole, it could set the stage for a massive ice age. This powerful feedback loop, driven by the geography of a supercontinent, could plunge the entire planet into a deep freeze. During supercontinent assembly, continents collide and immense mountain ranges are pushed up. That weathering draws carbon dioxide out of the air and locks it into limestone on the ocean floor. With less CO2 to trap heat, the planet cools. On a large scale, this can trigger a global ice age, an icehouse planet. Conversely, breakup of a supercontinent can have the opposite effect. Rifting stretches and tears continents apart and brings massive, prolonged volcanic activity. This pulse of volcanic CO2 acts like a thick blanket, trapping more of the sun's heat. The planet warms dramatically. However, the breakup of a supercontinent triggers a profound evolutionary shift. Isolation acts as a catalyst for evolution. The incredible and unique wildlife of Australia is a direct result of long isolation. Breakup forms new coastlines and shallow seas. The shallow, warm continental shelves are ideal nurseries for marine life, leading to explosions of diversity. From the first complex cells, to the age of dinosaurs, to the rise of mammals, to the journey of our own human ancestors, the shifting face of our planet is the very stage upon which the grand drama of evolution has unfolded. We have seen how geologists, acting as detectives of deep time, have pieced together this incredible saga. They have followed the clues, the puzzle-like fit of continents, and the matching scars of ancient mountain ranges torn asunder by opening oceans. The supercontinent cycle is the master control. The very stage upon which evolution has played out is a drifting one. The world we know is just a single frame in a much longer film. The forces that built and broke Pangea are still at work today, deep beneath our feet. In hundreds of millions of years, they will merge once again to form the next supercontinent. This deep perspective changes how we see our world. It reminds us that the features we think of as permanent, the oceans, the mountains, the continents themselves, are all temporary. The mystery of Earth's hidden supercontinents is, in many ways, solved. Yet the story is far from complete. The quest to understand our planet's past is a journey that never truly ends. By continuing to explore this incredible saga, we deepen our connection to the Earth and gain a more profound appreciation for the restless, beautiful, and ever-changing world that is our home.